Hey guys, so this video lesson is going to be over inequalities in one triangle. So the last lesson that you just learned is going to be important for this because this is kind of taking last lesson and just kind of going a little bit further, doing a little bit more. So there's a couple properties and corollaries and theorems that you need to be familiar with. Remember that with proofs, these properties, theorems, and corollaries are going to be used in your reasons. So make sure that you understand the theorems and the corollaries and the properties so you can use them for that aspect as well. So the first one is the comparison property. Basically, if A is equal to B plus C and C was greater than 0, then that would mean that A would be greater than 0. The second one is the corollary to the triangle exterior theorem. And what this basically says is that if you have a picture of a triangle, which you see right here, and it has an exterior angle, that exterior angle is going to be greater than the two remote interior angles. So angle 1, if angle 1 is an exterior angle, then the angle 1 is, the measure of angle 1, is greater than the measure of angle 2, and it's also greater than the measure of angle 3. The next theorem doesn't have a name, but basically what this says is that if xz, so this bottom one, is greater than xy, then the measure of angle y, which is the opposite of xz, is going to be greater than the measure of angle z, which is opposite xy. So we can order our angles by knowing the lengths of the sides, and we'll see an example of that in just a second. The next theorem is says, it doesn't have a name, but it says if the measure of angle A is greater than the measure of angle B, then BC is greater than AC. So if A is bigger, that's the bigger one. If A is bigger than B, then BC is bigger than AC. So angles and sides being opposite of each other do have a relationship in that manner. And the last theorem actually has a name, and it's called the triangle inequality theorem. And what this theorem says is that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I add any two sides of a triangle together, it should be larger than the third side. If it's smaller or equal, so if the two sides are less than the third side, so if I add two sides together and they're less than or equal, it is not a triangle. That's really important, okay? So our first example, use the figure at the right. Why is the measure of angle 2 greater than the measure of angle 3? So if you look at angle 2's position and angle 3's position, angle 2 is not considered an exterior angle because basically it has to be created by one of the sides of the triangles. However, if you look at angle 1 is an exterior angle, and BC is congruent to DC. So if BC is congruent to DC, that means that angle 1, the measure of angle 1, I should say, is equal to the measure of angle 2. And if that's the case, if we know that angle 1 is greater than the measure of angle 1 is greater than the measure of angle 3, then we can actually substitute the measure of angle 2 in for there and say that the measure of angle 2 is greater than the measure of angle 3. So by recognizing that this triangle was isosceles, we're able to go ahead and use this process right here. And you can actually write that into a proof. I'm not going to in this case, but you can actually write that into a proof. And you can say that the measure of angle 2 is greater than the measure of angle 3. Next example, a town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? So what you need to do here, remember from the theorem we said where the largest side is opposite the largest angle. So if we look for the largest side is Hollingsworth, and it says which two streets form the corner with the largest angle. Well, if we look for the largest side and we point across from it, we'll see that this angle right here is going to be the largest angle. So the two streets that form the corner with the largest angle are MLK Boulevard and Valley Road. So again, largest angle is across the largest side. 175 is the longest side, so the angle that's opposite or across from it is our largest angle. So on the top is another example, which choice shows, and there's actually not going to be a choice, so let me get rid of that. Which sides of triangle TUV are in order? Well, actually, let me just totally reword this. So let's list the sides from shortest to longest. When you list a side, you need to have the segment line above it because you're just talking about the side in general. In this picture, notice that we have a triangle and two of the angles are given. So in total, we know that it's 180. So we need to subtract the sum of 58 and 62. So if we add 58 and 62, we find out that that's 120. Subtract that from 180 and you get that this is 60. By knowing that, we can now figure out where the opposite sides are and which ones are going to be the largest and the smallest. This is the largest angle, so this is the longest side. This is the smallest angle, so this is the smallest side, which means that this side is going to be the middle. So, longest side is TU. Next is the middle, which is UV. And the last one is TV. And that's it. If it wanted from shortest to longest, we would just need to flip that order. Towards the bottom of the screen, you'll see a proof. This is the triangle inequality theorem, and it's actually proven. This type of proof is called a paragraph proof. And basically, a paragraph proof is the same thing as a two-column proof. The only difference is that we actually just write it in paragraph form, so it's in sentences, basically. It's not writing it just in statements and reasons. So you can actually take a two-column proof and write it into a paragraph proof, and you can also take a paragraph proof and turn it into a two-column proof. But just take some time to read that, and we'll actually talk about that theorem tomorrow in class. Last two examples. Can a triangle have sides with the given lengths, and explain? So we're given 3, 7, and 8. So what you're going to have to do here is check to see if when you add any two sides, is it going to be larger than the third side? If that's the case, then it's a triangle. If that's not the case, then it's not a triangle. So 3 plus 7 is 10. 10 is greater than 8, so that's correct. 3 plus 8 is 11. 11 is greater than 7, so that's great. And 8 plus 7 is 15, and that's greater than 3, so that's good. So yes, the sum of two sides, I should say of any two sides, the sum of any two sides is greater than the third. And here's the thing. When you explain, it doesn't need to be fancy. It doesn't need to be, like you're getting your PhD or anything. But your explanation does need to be in a form or a manner that would make sense. You don't need to add a whole bunch of extra words in there to make it look fancy. That's not necessary. So something simple like I just wrote would actually be perfect. Okay? Now, if one of these that we just did, if one of those did not work, then it is not a triangle. All three must be true. All three must work in order for it to be a triangle. Okay? And then the last question. So in Pearson, you can look at the solve it problem if you like. Two of the sides of the sandbox are 5 feet and 8 feet. What is the range of possible lengths for this third side? So doing what we did up there in the above, we can actually use all three sides and create three different inequality formulas here. So we know that in order for it to work, x plus 5 must be greater than 8. Well, if that's the case, we can just solve and figure out what x is, so x needs to be bigger than 3. We also know that x plus 8 needs to be bigger than 5. So what that means is that x needs to be greater than negative 3. And we also know that 8 plus 5 needs to be bigger than x, so we know that 13 needs to be bigger than x. So what does all that mean? Well, the numbers need to make sure, or we need to make sure that the numbers satisfy bigger than 3, bigger than negative 3, but less than 13. So what that means is that x needs to be greater than 3 and less than 13. Now notice that I didn't use this part. Reason being that if x was, say, 2, and I plugged in 2 right here into this one, 2 plus 5 is 7. 7's not greater than 8. So it wouldn't satisfy this one. So 2 and 1 would not be possible. Obviously, negative numbers cannot work either because you cannot have a negative length of a triangle. So in this case, that would be our answer. Now you can write that in words instead. You could say x needs to be greater than 3 and less than 13 in those words, but either way would work. So if you have any questions, don't be afraid to ask. Make sure you pause, rewind, go back into a certain place if you need. And I hope you guys have a great evening.